Hello everyone, now I am going to explain the project. The project title is Soil Moisture Monitoring and Automated Suggestion System for Precision Agriculture using IoT. This system aims to provide accurate and real-time information about the soil moisture content, which is critical factor for crop growth and yield. Traditional methods of soil moisture monitoring and irrigation are time-consuming and labor-intensive, which makes it difficult for farmers to maintain optimal soil moisture levels. The proposed system uses sensors to measure the soil moisture and soil moisture content, and the data is transmitted to a cloud server using IoT technologies. The cloud service processes the data and generates the reports. The system includes components such as soil moisture sensor, IR sensor, DHT, node MCU, buzzer and single channel relay and water pump. Here Node MC is an open source firmware and development kit that is built around the ESP2866 Wi-Fi chip. The ESP2866 chip is a low cost and low power, highly integrated chip that enables Internet of Things applications by providing Wi-Fi connectivity. The operating voltage range of ESP8266 is 3 to 3.3 voltage. And here we are using DHT11 sensor. It detects the temperature and ultra low cost digital temperature and humidity sensor, and it takes that 3 to 5 volts power and 2.5 milliamps max current used during the conversion, good for 20 to 80% humidity readings and good for 0 to 50 degrees Celsius temperature. And next we are using IR sensor. Is an electronic device that is designed to detect infrared radiation emitted by the objects or materials. Here we are using this for the detecting the animals while entered into the yields, and unknown persons also can be detected by this sensor. And another one, here we are using the soil moisture. Soil moisture is an electronic device that measures the amount of moisture in soil. The sensor typically consists of two metal probes that are inserted into the soil. And next, here we are using the water pump. If the moisture level in the soil drops below a certain threshold, the system can activate the pump to deliver the water to the soil until the moisture level reaches the desired level. The operating voltage of water pump is 2.5 to 6 volts and the operating current 130 to 220 milliamps. Flow rate, it can flow 80 to 120 liters per hour, and it is connected to the single relay channel, and the connections are made as per the code. The DHT, all VCCs and all grounds of all sensors are given to the VCCs and grounds of breadboard, and DHT output pin is connected to the D4 pin of node MCU, and D0 pin of IR sensor is connected to the D1 of node MCU, and the A0 pin of soil moisture is connected to the A0 of node MCU, and the relay is connected to the D8 pin of node MCU. If the temperature is greater than or equal to 25 degrees, the motor will on automatically. If the temperature is less than 25 degrees, the pump should be off, and we can change the conditions in the code according to our needs. And the relay is connected to the 9 volts battery, and here to supply the power to the node MCU, we can connect it to the power bank. Start. This is about the hardware part. Now we have to see the output in the Azure cloud. This is Azure portal, and here we have to select IoT Central Applications, and here I am going to create new device. And new resource group, naming soil moisture. I am giving the same name here. Template custom application and region Southeast Asia and review plus create. Deployment is in process. And go to resource. Here we have this link. Click on this link. We'll enter into the devices. And click on add a device. And here we have device name, device ID and device template. We can change the device name and device ID, but I am not changing here. Create. And click on this new device. And we have to create device template. IoT device. Customize. Here we have to give new device template name. I am giving moisture 9. Device template is created. And next devices. And here connect, click on. And copy this scope ID, device ID and primary key and paste it in the code. Go to devices and we have to create capabilities here. First I am creating moisture capability. For moisture, semantic type is relative humidity. And click on save. And next I am creating temperature, humidity. For humidity, semantic type is humidity. And next temperature. Semantic type is temperature. And click on save. Now publish these capabilities. Here we have got views no, so go to views. And click on generate default views. Click on generate default dashboard views. and click on publish again. Now go to overview to see the results. Select the any type of graph. Here I am selecting bar chart and save. We have the results here. The moisture content is 1.64% and the humidity is 66.33% and temperature is 32.57%. And these are the results in the Azure cloud platform. And the moisture is presented in the soil content, and humidity and temperature are around the soil content.